So in this lecture we are going to study about how to increase the heat flow to and from the PCM materials. So we said that the high thermal conductivity is desirable. So we desire high thermal conductivity. High thermal conductivity. So if we have phase change material, so in order to increase as much as possible the heat flow inside our component, we can think to work in various different ways. So first way is to increase the surface to volume ratio. So if we have a tube, we can think of some small cylinders filled inside with PCM. So suppose if we have a tube, we can think of it is filled with many cylinders. Inside the cylinders there is PCM material. So this is to improve the surface to volume ratio. So other possibilities encapsulation, which we have studied in the previous lecture. So we have formulation of our capsules that can be inserted inside a tube and can exchange in better way with our environment. Now other ways to add any high thermal conductivity phase in the PCM material. So we can think of as graphite. So graphite has a good thermal conductivity. So we can add graphite to our PCM to improve its thermal conductivity. So in principle, we can think to add graphite to our PCM in order to improve the thermal conductivity. So we don't want our added element to segregate. So when the PCM is liquid and then solidifies again. Other way is percolation of the PCM in high thermal conductivity structures. So basically percolation means liquid slowly passes through a filter. So we can allow a PCM material to form networks embedded inside our shell material. Let's imagine we have a tube with diameter 76 mm. So the diameter is 76 mm and it has thickness of 1.6 mm. So it has thickness of 1.6 mm. We see that a PCM is filling our tube 80%. So we fill our tube with the PCM 80%. So and 20% is accounting for the empty space. So why we need this empty space? So this is empty space. So basically this is empty space here. So why we need this empty space? So when we move from solid to liquid, we have expansion of our component. So in order not to break our shell, we need to account for empty volume to maintain the system stable for the longest time. So I think we have covered all necessary aspects in this lecture. In the next lecture, we are going to study about the composites PCMs in order to tailor the properties. So for now, thank you.